In our life, we always see something rotating. One of it is like this wind turbine. So if I put a point at the end of the blade, so the tip of rotating blade, suppose it is described by the function yt, y as a function of time, equal to 3 cos 2 t plus 4, where y and t are in meter and second. Could you locate the coordinate of these points after 30 seconds in xy plane? Hi, I'm Dr. Kat. In this lesson, you are going to learn about angle and trigonometry. At the end of this lesson, you will be able to relate between the measure of angle in degree and radian, and also solve problem related to trigonometric function. Let us start with the radian and degree measure of angle. Okay, let us recall again about the circle. So this is a circle. It has center of O, and this is an angle measured in the sector POQ. This is POQ, the sector, and angle is theta. And this angle usually in the Babylonic practice, so they divide one circle into 360 pieces, where one piece is equal to 1 degree. So that is the measurement of angle in degrees. And for the calculation, it is best if we can use radian measure instead of degree. So we have is a radius. The circumference is any peak along this arc of PQ. So this is arc of the PQ. So the circumference is the length of the perimeter of the circle. Okay, so a circle, as I said before, can be divided into 360 equal sector, each 1 degree. And PQ, the arc of PQ is proportional to R, right? Because if R increase, PQ also increase. And in the same way also, the theta also increase. So in that case, the multiplication of R and theta increase with the arc. So to define it well, the arc is equal to the R multiplied by theta, and make sure the theta is in radian. So that is the definition of theta, where theta is the ratio between arc PQ. Okay, theta is the ratio of the arc PQ and over the radius. Okay, for easy memorization, you have to equalize the degree of 390 degree is equal to 2 pi radian. So that if you want to find out 1 degree, you just bring it down here. Or you want to find out what the 1 degree is, just 360 divided by 2 pi. So this will become handy if you want to convert between degree and radian for angle measurement. Now let's go into the polar angles. What is polar angles? So in problem regarding of angle, we have to fix the angle position where we want to measure. Okay, so for example here, if you have a line, the lines between the angle between this axis x and the line is theta. Okay, this is 1 over 4 pi, which is, this is about 45 degree. So in angle, it is 1.4 pi. But when you put here, even though it is 45, you have to write it as minus 45 or minus 1, negative 1.4 pi. So this is called a polar angle. Polar angle determine the sine of the value, the angle that we measure, so that they determine the sine. So if you calculate from x and it is anti-clockwise or counterclockwise, it is just the same. Anti-clockwise and counterclockwise is the same. If you follow the measurement counterclockwise, the value is reported as positive value. And if you use clockwise, you use negative notation or sign. Okay, for example, if you calculate from here, again this is positive, right? So in the counterclockwise position, so this is positive, so this is pi, this is another half pi, and this is quarter pi. So you have 1/3 over 4 pi. Okay, so even if you do it multiple times in the counterclockwise position, you have to use positive number. Okay. Now we go to the trigonometric function. You have learned about it before, but let's relearn again about this. So for cosine function, we can use cos theta, and referring to these coordinates. So if this is theta and this is the point, so this is the radius, which is also equal to the hypotenuse. Okay, hypotenuse of the function, and this is y and this is x. Okay, all right. So the value of the theta is calculated from here. Okay, so you can have this is equal to the what we call it, the base divided by the radius by using the polar coordinate here. Okay, so you have cosine, sine, and tangents. And we have an additional trigonometric function, which is secant, cosecant, cotangent. Okay, secant is written as sec theta, secant, equal to 1 over cos theta, or it is also equal to cos theta. You have to bracket it, and it is minus 1. So take note that this is not equal thing. They are not the equal expression. If we look further, what is this one? Okay, if you have any value of y equal to cos theta, so the arc cos y equal to theta, if you bring it to the left, you will get arc cos, and this arc cos can be written as cos theta minus 1. Sorry, cos minus 1. So that means this is equal, but this is not equal. So be careful. Alright, so similar for cosec, there is 1 over cos theta or CSC theta. Cotangent is theta equal to 1 over tan theta. Okay, or this is tan theta minus 1. Right. So for the value of this sine cos theta will take turns on the quadrant. So this is we call a first quadrant, second quadrant, third quadrant, fourth quadrant. Okay. So if anything, any measurement here, for example, the value. So the value of theta when the turn is here, only sine theta will give you positive value. The other will get negative. If only for the first quadrant, all of these value will take positive value. Next, these graphs are very common in science because many physical quantities change periodically. Okay, and the study in physics involve wave. So the wave, it has a this kind of function. It involve cos and sine function. All right. So let's look to this sine graph, which is cos graph is a purple, sine graph is the blue color. Okay. So cos graph, it has one value 1 at 0, and for the sine, it has 1 at half pi, which is half pi is equal to 180 degrees, right? Okay, so what's the relation between this cos and sine graph? So sine theta is equal to cos theta shift to the right by half pi. What does it mean? Okay, so if you have this purple, if you shift it to the right, so they will override. Exactly the purple, if you shift by pi, half pi to the right, so you will get exactly purple on the blue. So that means if you shift it to the right by half pi, you get sine. So cos graph, okay, that means if you move to the right, means that means you have to subtract the value. Okay, so you will get the sine graph. So if you have cos graph, shift to the right by subtracting the value of half pi, you get sine theta. Okay, and sine theta is an odd function. Similarly, if you shift the sine, to the left, that means you have to additional in the argument, so you will get sine. Okay, so if you shift sine to the left, okay, to the left, so this blue to the left, you get it on the purple with a proper additional value here, and cos is an even function. So both of them are periodic function with the period of equal to 2 pi. Okay, so they have they will repeat again themselves every 2 pi. So that means, so it repeat again, and then it oscillate between 1 and -1. So these are important property of the cosine and sine graph.